So in this video I'm going to prove the derivative with respect to x of the cosine of x. And to do so I'll need my definition of the derivative, which is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. I have it written there at the top. It should look familiar to you. We used it in the tangent line problem. I used it in the proof for the derivative of the sine of x. And we use it for practically all of our proofs for derivatives, except a few exceptions. We may take some alternate form to prove it. But this is our definition of a derivative and where we derive all of our formulas and things. And secondly, I have the cosine identity for the sum of angles. I have it written here: cosine of alpha plus or minus beta is equal to cosine alpha cosine beta minus or plus sine alpha sine beta. And this is a chance for you to review your trig identities. We use them a lot in proofs and throughout calculus, so they're quite useful when we have to start manipulating things, and particularly with these derivative proofs. So to begin, let me go ahead and write out our definition for the derivative of the cosine of x. It's the limit as delta x approaches 0 of the cosine of x plus delta x, because cosine of x is our f of x, minus the cosine of x, all divided by delta x. So to evaluate this limit, we'll use our sum of angles identity. So I can rewrite this as the limit as delta x approaches 0 of the cosine of x times the cosine of delta x minus the sine of x times the sine of delta x. This is just using our sum of angles identity from trigonometry. And then behind that is a cosine of x, all still over delta x. So we just expanded this with our sum of angles identity to get this form. Next, let's group some terms together, and hopefully you'll begin to see the proof taking shape. So we'll group our first term here with our final term out here. We'll get the cosine of x times the cosine of delta x minus the cosine of x all over delta x. And then splitting the fraction, we'll have minus our middle term there, sine x sine delta x over delta x. Now from here, we'll factor out some terms and it should begin to look pretty familiar for you. So we get the limit as delta x approaches 0. On our first term, we'll factor out a negative cosine of x. When we do that, we're left with negative cosine delta x plus 1 over delta x. On our second term, we'll factor out simply the sine of x, and we're left with the sine of delta x over delta x. Now hopefully this is beginning to look familiar for you. Our first term here is our squeeze theorem identity, 1 minus cosine delta x over delta x. So our limit as delta x approaches 0, we know from the squeeze theorem, is 0. And on our second part here, the sine of delta x over delta x, the limit as delta x is approaching 0 is 1. And we've proven these through limits and by our squeeze theorem. So when we simplify from there, we've taken our limit and we're left with the cosine of x times 0 minus the sine of x times 1, which we can then simplify because anything multiplied by 0 is simply 0, and we will get the derivative with respect to x of the cosine of x, which is where our problem began, is equal to the negative sine of x. And notice that the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. So they just keep going back and forth between one another, but remember the derivative of sine will be positive cosine. The derivative of cosine is negative sine.